to this video on closure in Swift. Have you ever wondered why Swift allows you to write such a compact code and is still very expressive when you use map, reduce, filter kind of functions? Well, in this video, we will take a look at why it looks so precise, because ultimately these are just functions, but it looks a bit different. Now, if you're a complete beginner, then I'll share a piece of code real quick with you on the screen, this one. Now this is a code which is using Swift and SwiftUI both. Now I want you to ignore all the code and come to this filter function. And it has some logic in it and it has curly bracket. It doesn't have parenthesis, right? It's a function but don't have parenthesis, and it looks quite compact, right? Well, the secret is it is a closure actually. It is everywhere. It is in every Swift file when it comes to enterprise level application code. When it comes to SwiftUI, it's almost in every file, and combine concurrencies, it's everywhere. So by the end of this video, you will actually understand closure inside out. We will take a look at not only how the closures are derived from a simple function, we will also take a look at the forms of closure when we are deriving closure from function. Then we will jump into some examples which will give you a clarity on the syntax, the forms of closure even more. Then we will jump to the application of closure, for example, passing the closure as an argument to a parameter of another function. And we will recap on everything we have learned in this video. So grab your Xcode and let's dive in. Now, as part of the first step, what I'm going to do is remove this func keyword and the name of the function. So this is the func keyword and the name of the function. Let's remove it and bring this open curly bracket in the front and leave the in keyword behind at its place. Now this is a closure. All we have to do is give it a name and test it by calling it. I will name it first closure. Since this is the outcome of first step, I'm naming it first closure and I'm gonna just call it by giving it some random values. I will also print the output. We got 6, so it works. And now in the second step, we can remove the input types and output types. So let's remove the input types, which is integer and integer, and the output type is integer again. Now we can see there are a couple of things which are extra. Since we don't have the input types, we don't need the colon. And since we don't have the output type, we don't need the arrow. I will remove some extra space. Now we have to give it a signature. So because there are two parameters of type integer and we are returning the value of type integer, this becomes the signature that we have to mention to the name of the closure. Now to test it, I will change its name to second closure just to make it more sensible, and I'll change the values, give it some random values and run it. 36, it works. And let's move to the third step. We can remove this return keyword just like that. I will change the name and test it, giving it some random values, running it. It works. And in the fourth step, we can remove the input variable names as well. Here the input variable names X and Y. So let's remove them. Now again, there are some unnecessary things. We don't have the input names here, so we don't need this comma, this parenthesis, and the in keyword as well. I will remove some spacing as well to make it look more concise. This is it. Here the question arises that what happens to X and Y? Well, this is where the dollar comes into the picture. We can use the $0 to refer to the first argument, that is X, and $1 to refer to the second argument, which is Y. And that's it. This is our closure. Let's test it. I will change its name to fourth and call it with some random values. It works. Let's give it some another value. It works. So now you have seen the 4 forms of closure. What I'm going to do is the whole process that you have seen of converting a function into a closure, I'm going to write it in a more systematic manner. We will start with the first step. We'll start with the full function. That is, in the first step, what we did is remove func keyword and name of the function, and then bring this open curly bracket this in the front and leave in keyword behind. That's it. So I'm gonna do is copy this thing and paste it here and follow the step. Remove the func keyword, the name of the function, bring this curly bracket in the front. I will drag it, okay, and leave the in keyword behind it, its place. At every step we are giving it a name and testing it because that is intuitive. Now let's give it a name. Let's give it some random values again just to test it. In the second step, what we did is we remove input and output types. So I will copy this whole thing, comment it, paste it here, and follow the second step. And at every step, we have to remove some unnecessary things. So I'm not gonna write it here, but it's it's gonna be very intuitive to you. And that's it. We have changed its name to second and call it here, giving it some random values just to test it. I will run it. Oh yes, as part of the second step, we have to give the signature. Never forget to give the signature for the step. And third step is quite simple. We remove the return keyword. I'm gonna copy this, comment it, paste it here, and remove the return keyword. I'm going to name it third and call it. Testing it, it works. In the fourth step, we have removed the variable names and used shorthand arguments names, that is $0 and $1 to refer to X and Y. I'm gonna copy this, comment it, paste it here, and let's do it. X and Y are variable names, removing it. Now again, as part of every step, we have to remove some extra things, that is this comma, parenthesis, and the in keyword. I'm gonna bring it here to make it look more compact. Changing the name and calling it, giving it some random values and testing it. Oh yes, I forgot to give the shorthand names, that is 0 and 1. That's it. These are the 4 forms of closures that we have seen, and we have converted a function into this single line closure, which we generally call inline functions. I will uncomment all of it, and this is something that you can use for reference. You will find this file in the video attached down below. I hope this gives you a clarity on the forms of closures and how the closures are actually derived from a function only. And that is what makes it so compact, because we remove a lot of things from the syntax of the function, and mostly because it can just the Swift compiler can infer those things automatically. We take a look at the application of closures, where we will talk about all the functions like map, reduce, filter, and compact map, like that. We have to take a look at one of the application of closure, which is passing a closure as an argument to a parameter of another function. And to take a look at that, I will create a small function named calculate, and let's create one parameter in that, to which I will pass my function or closure. So here I have 3 parameters, x and y, which just expects one value of type integer, and this is my third parameter and the last parameter of calculate, which is where I'm going to pass my closures. So I'm going to pass all the forms of closures one by one, which is fourth closure, third closure, second, and the first. And also I will try to pass the function itself. Now to pass a closure, we have to give it some type. That type should be same as what you're passing to it, that is the closure. So the type of the closure is this. So I'm going to copy this and paste it here. Now I'll complete this calculate function. What I'm going to do is call that function inside the body of calculate, and I'm going to pass x and y to it. And what closure will do is, this is the closure body, it's going to give us the summation. So I will print it here. Now let's call this function calculate. I'm going to give it some random values. And here I'm going to just pass my closure by using its name. I can pass a closure with the name, and let's do that first, and then we will see the second method to pass the closure as an argument to the parameter of the function, that is passing the body. So this is the name, this is the body of the closure. This is the closure name, and this is the closure body. This is the name, this is the closure body, this is the name, and this is the closure body. We are just passing closure name, and what I'm going to do is comment all the print functions. Let's call it. It gives us 6. So what it does, it takes this 3 and 3 x and y values when we call calculate here, and we have passed a function and we have called that here, and we have passed the values. So this values goes to this function, and it comes to the fourth closure, which is here, and it executes its body, and in the return what we get is the summation, and we get the summation here as the resultant, and we print it. So that is the flow where we are passing the closure name as the argument to a parameter of the function. Now let's try passing third closure. So I'll copy the name, pass it here, and let's change the value and test it. It works. Let's try passing the second form of closure. I'm going to change the values, run it. Now let's give the very first closure form, changing the values, running it. And that's it. We can pass all the forms of closure. Now let's try passing the body of all the forms of closures. So starting with the fourth closure, this is the body, and I'm going to just copy this, and I'm going to paste it here. And let's run it by changing the values. It works. Let's try again with some other value. It works. So the flow is still same. What happens is it takes the value x and y here, and it takes the closure body. So here, instead of name, we are passing the body. When we call the function with this as arguments, it goes to this closure body, executes this part, and once it is done executing this part, we get the resultant here and we print it. So the flow is something that you will slowly, it becomes catchy. The more you use closures, the more you will understand the flow of it, and it is all nothing but just practice. Now in this example you have seen that we are passing the fourth closure body. Let's try passing the third closure body. I will copy that and paste it here, and let's change the values and run it. It works. Now let's try passing the body of second closure. I will copy the second closure body, paste it here, change the values, run it. It works. Now let's pass the body of the first closure. Let's change the values, run it. It works. Now these were the 4 forms of closures we have seen, and we have passed them as an argument to a parameter of the function, and we can either pass the closure name or the closure body also. Now when it comes to the function, can we pass the function as the argument to the parameter of the function? Well, let's try with the name, and then we will try with the body of the function. Let's try with the name. I will copy it and pass it as an argument. Now let's run it. I'll change the values. It works. But when it comes to the body of the function, I will copy it and paste it here. It won't work. It throws some sort of errors here. That is one of the simple reason why we need closures. I will do this change and keep it added so that we don't see the error. Now that we know what closures are, how they are derived from a function, what are all the forms are there, and how we can pass them as an argument to a parameter of a function, we can now take a look at some of the examples.